All right, I will try to answer some of these questions as we go through the class today. Yeah, welcome back. We're at week 3, which is crazy. We're almost halfway through class already. Um, this week's gonna be kind of a fun one. I think we're gonna start to explore some really cool stuff to really get to like really customizable applications for this stuff. So we can dive right in. I would also say if you have not yet started, if you're a Run Comfy person, maybe not yet started your Run Comfy instance, go do that now because we're kind of gonna dive right in immediately. And like the first thing we're gonna do is spend a lot of time uploading stuff. We'll kind of burn through a little bit of money just uploading some files, but it's better just get started now and do that. So um, start that, and then while I sort of riff for a little bit, then we'll jump into that and we'll talk through some things. We'll also share the links to the slides for anyone interested. All right, let me share my screen. Cool. Chat. Really wish Zoom would just remember my configuration. Always set up the same way. All right. So this week we're going to continue from where we sort of were last week, which is I hope everyone was able to train a LoRa. If you weren't, that's totally fine. I have already shared in our Slack channel some LoRas you can get from me. And we'll go over a little bit more about that as well. So we're just going to basically, I know a lot of people are like, hey, I trained a LoRa, but you never told us how to load it. So we're going to look at that this week. We're going to look at loading a LoRa, using a LoRa. We could even look at combining LoRas, like all sorts of stuff. There's a lot of things we can do with LoRas. And then we're going to spend probably the last half of class looking at a tool called IPAdapter, which is basically like LoRa's for single images and without train time. So like it's pretty cool as well. And like the cool thing about the IPAdapter node in Comfy is that the person who builds it is like very active on YouTube. And while the text documentation for IPAdapter sucks, he records a lot of videos that are really helpful. So I will basically just be like reteaching one of his videos. But there's a bunch of other videos on his website as well if you want to really dig into this stuff. So as I mentioned, like if you haven't started your Run Comfy instance, do that now because what we're going to need to do first is upload our LoRa to Run Comfy. And even though the files are quite small, it can still take a couple minutes. So make sure you have it started. Before we jump into this, I also want to mention last week during Q&A, I think Jessica, Daya, and I were talking about this new model called AuraFlow, which was trained by this team at Fall, FAL. I don't know how you pronounce it. It's sort of like the person who made it is essentially someone who was just basically trying to like rebuild stable or like trying to understand how diffusion models worked beyond, the basic demo. And he got funding from this group Fall, and they've already released a version 0.2 of AuraFlow. About 3 weeks ago, I think they did 0.1, and then this week they did 0.2. So I have recorded a tutorial on what's cool about it, how to load it. The model file is 18 gigabytes. So downloading that and installing that is kind of a pain in the ass. The other thing is in order for AuraFlow to work in ComfyUI, you need the latest version of ComfyUI or like the version of like 2 or 3 weeks ago. And unfortunately, you cannot install that and run Comfy right now. My hope is that the next iteration of what they release on Run Comfy in hopefully a week or two will include this, but right now it doesn't. So if you want to play around with ComfyUI, or if you want to play around with AuraFlow in ComfyUI, you do need to either use Colab or your local system. I recorded this tutorial on Colab, and I think there was even a tutorial from maybe week 1 or week 2 on using Colab for Run Comfy. So, or sorry, for ComfyUI. Getting all these different platforms mixed up in my head. So if you want to run, if you want to experiment with ComfyUI and Colab, you can definitely check out this video as well as the previous one. It's kind of a fun model. It's definitely not as good as sort of like SD3 and maybe not even as good as SDXL. But one thing it's really good at is it's good at composition. So if you want to say something like, I want a cat on the left and I want a human on the right, it can actually do that. Whereas a lot of other models really struggle with sort of like, okay, I put this where, I put this here on what part of the screen, like that sort of thing. So we looked at how to do that with some like masking. last week. But if you want to kind of get it out of the box with a model without having to play around with masks and stuff, Auraflow is actually quite good at that. So that video is there for anyone interested. It's also linked to from our syllabus. So we're gonna look at LoRa's for the next hour-ish. I recorded like a 20-minute recording after class last week and put it in our notes. But if anyone didn't get to watch it, I'll give you like the very high level reason that LoRa's are cool. LoRa's are essentially this sort of like extension based on a base model. So imagine that this is our base model, with our 6 gigabytes of files. Our little LoRa is like, in the case of like an SDXL, is like 500 megabytes. And it like sort of changes the composition of our base model. So you can imagine like this affecting certain nodes within our base model. And what's really powerful about this is that it gives us the opportunity to basically make a bunch of LoRa's very quickly without having to train an entire new model. And without having to also have millions of 6 gigabyte files on our systems that are flying around everywhere, right? So the cool thing is that it's easy to train. I think most of us probably trained something. Took maybe an hour or two, maybe 3 hours at most. And you can now do that. I think Sean was saying he's trained like 4 LoRa's over this week. You could probably pretty easily do a LoRa a day with like the amount of data you need, that sort of thing. So what you end up with, and we'll kind of look at this week, is like you end up with this base model that's massive. But then you can also end up with like a bunch of LoRa's that are easily swappable in and out. You can actually even combine LoRa's as well. So say you've got a really cool LoRa that does cyberpunk and then a really cool LoRa that does something else. You can also like kind of combine those into a flow to generate different types of LoRa's as well. So there's a lot of opportunity here. The thing that is important to remember, and this sort of was kind of trying to highlight in both last week's lesson as well as in the tutorials for training LoRa's, is you have to make sure that all of your models match. So if you train a model on SD 1.5, if you train a LoRa on an SD 1.5 base model, and then you want to add another LoRa, you've got to make sure that LoRa is also on SD 1.5. The challenge here, and I think I've certainly ran into this with the Civit AI training, is that once I set up all those parameters, Civit AI never told me what the base model was after I set it up. So the UI for that is a little funky. Thankfully, I was recording that as a tutorial, so I was able to go back and kind of figure out which one went where. But it's especially with Civit, which is like the cheapest one and maybe like works pretty well. It was definitely something I had to keep track of. So if you went through and did that and you don't remember what base model you used, you might not be able to get back to it. Maybe able to reverse engineer some of it based on the model size. But you might need to train it again, which just means like a couple bucks more, unfortunately. But yeah, so like this will be one of the things we talk about sort of as we go through everything, including when we hit IP adapters. Like pretty much anything that happens in Comfy, your base model defines everything else you can do from there. So for example, Auraflow, which is this new model that just got released, there's not yet a LoRa training system for it. So you can't add LoRa's to it. There's not yet an IP adapter system for it. So you can't add IP adapters to it. There's not yet control nets, we'll talk about next week for it. So, or actually, I think someone just released a control net for it. But essentially, the reason that you see a lot of people in the community care mostly about SD 1.5 and SDXL is because LoRa's exist for them, IP adapters exist for them, and control nets exist for them. So we're kind of like locked into that ecosystem because of all these other tools. Now, as new models come out and as hopefully people invest in them, we'll begin to see these other things may become available. But until then, we're kind of stuck with some of the stuff that already exists. So SD3, which is the newest stability model, came out, I think, about a month ago. I think I've just seen people like LoRa's came out pretty quickly after for that because it was based on the stability architecture. I think I've yet to see them do IP adapters for them. And I've just started to see control nets come out for them. So all of this is like a new model comes out and people get excited, but then it's like, well, wait, are we going to get these other tools for it yet? Kind of becomes a hindrance there. So yeah, so the biggest thing is just remember that as we build up our LoRa's, we need to make sure that the base model connects to them. And this is where something like Civit is kind of cool because Civit allows you to also change out different models, right? So you could make an XL model of the same data set that you made an SD 1.5 on. Like being able to do that work allows you to have different dependencies. So when we talk about animations in a couple weeks, animations are almost exclusively built on SD 1.5 because of legacy issues with some of the animation nodes. So not a lot of SDXL models that work for animations. What that means is a place where like Eden, which is focused on making cool images, the Eden trainer only works for SDXL. There is no SD 1.5 yet. I've been told they're working on it. This gets complicated because we might want to make images that we think are cool and then feed those into an animation model, and it's going to be kind of a pain in the ass. We'll have to do it in 2 steps rather than 1 because, well, the model's not connecting. So this is just going to be a legacy problem we're going to face as we go through the rest of the course. All right, so let's talk a little bit about what LoRAs are going to look like in use, and then we'll just go ahead and start doing it. So when we open Comfy, we're going to want to select the base model we're going to work off of. 9 times out of 10, that's going to be SD 1.5 or SDXL. Then we're going to add our LoRa in, and we'll look at how to do that. We have to make sure that matches and maps to the correct base model. And then in most cases, when you trained your model in Civitai, you gave it like a keyword or something that was like a fancy like sort of tag to it. We're going to need to use that in our prompts. So in Civitai and Dreamlook, the 2 I showed you, you're going to need to use that keyword or that phrase. In the case of Eden, if you train an Eden LoRa, the correct keyword is actually not a keyword, it's actually a file. It's an embeddings file. I will not cover that today just because it kind of complicates things. And I imagine, did anyone use Eden? Okay, Dia used Eden. I know Dia is an Eden person. Okay, I might go over it then. We'll see how much time we have. But I did actually record a video on 2 things. I've recorded a video on how to upload base models to run Comfy. I'm going to assume that everyone did SDXL or SD 1.5 this week. If you did something else, we'll look at it maybe during break, and I'll try to figure out how to upload stuff for you. Uploading base models is a pain in the ass because run Comfy disabled or like broke wget. I don't know how they did that, but they did it. So what you have to do is you have to download these massive files, then upload these massive files, and it's just really slow. Like uploading a 7 GB file to run Comfy takes an hour. So it's just a pain in the ass. You can do it. And in fact, the thing is they've sort of hacked around it by making a free version. So you can use their CPU version, which allows you to upload files. You can't create anything with it, but it's basically free 20 hours per month of CPU time. So you can upload a model using that free CPU time. Once it's uploaded, then you switch to a GPU and then you can generate from it. But it's still a pain in the ass. I really wish they would just let wget work directly out of their system, but probably some security issues or other things that are happening there. So this video will walk through the way to upload checkpoints. If you train on like a custom checkpoint, like Civitai allows you to basically train a LoRa on any of their base models, including all the weird anime ones or all the weird girl ones. Like you can do it. You're just going to need to upload your base model to run Comfy in order to use it correctly. So just be aware of that. The other video I have, which I mentioned, is for Dia, I guess, or for anyone else that wants to play with Eden. Eden has a special second file that you need to upload into a different location. They're called embedding files. And that allows you to use their embeddings file in your text prompt. I actually think it leads to some of the best looking LoRas, but it is a little bit of a pain in the ass to use. And also Eden has a pricing of like, you have to pay $30 a month to be able to export your models out of there. So this video will cover how to export models and then how to import them into Run Comfy. So Dia, maybe you and I can chat later, or like we can work through it together during break. So just know that Eden, I think their LoRas are quite nice, but it does take a little bit of extra effort. Okay, cool. Let's jump into Run Comfy then and get started. So first thing we're going to need to do is I'm going to load my default view. And the first thing we actually need to use is our folder system. So if you have closed this by hitting this little X button, you need to click it again to open it. And the thing we need to do here is, okay, something really went wrong. Okay, great, thanks. Thanks, Run Comfy. Let's try this reloading our system here. Okay, so pretty much any model file you want to upload to Run Comfy, the biggest challenge is making sure you put it in the right folder. So to find the right folder, we're going to go into our file browser. And for those of you that are running local, it's the same file system. It's just obviously not within this GUI, but you can find those files pretty easily. So within the file system, we're going to go to ComfyUI, double click on that. Then we're going to go to models. We're going to double click on that. And you'll see there is a checkpoints folder. this is where we would put base models. So if we had a custom base model that wasn't available within Run Comfy and we want to install it ourselves, we would drop that in this folder. In the case of LoRAs, what we want to do is we want to scroll down till we find LoRAs. So double click on this folder and you'll see I have a bunch added in here. Don't worry about what I have here. Yours will probably be blank or will be like this put LoRAs text file here. So next we need to upload our LoRa. So I'm going to assume a bunch of you probably have train your own LoRa, in which case you should download it from either Civitai, Dreamlook, Comfy, wherever you, or sorry, Eden, wherever you made it, download it from there. If you did not make a LoRa, you can use mine. I will share this folder with everyone. This is also in our Slack channel, so if anyone wants it, they can have it. What I have done here is I've uploaded a bunch of things that I trained over the past week or two and some older models as well. In the case, I would probably say for now, skip the ones that are labeled as Eden and just look at the ones that are labeled either Civitai or Dreamlook. And I would probably recommend for this class, download either the SD15 or SD1.5 or the SDXL model. So let's actually download the SDXL model of this. And what I'll say is download the folder, not the individual files, because the individual files are not labeled very well. So if you download the folder, you'll get the folder name with it, and then you'll be able to make sure we put it in the right place. So I'm just going to go ahead and download this. Hopefully it doesn't take too long. Let's see. What is in here? Is this going to take a while? No, there's only one file in here. Okay. There we go. Okay, I kicked off. Cool. So actually, while you're here, you might want to download the SD15 as well as the Dreamlook version. So Dreamlook VinFlow SD1.5, Dreamlook VinFlow SDXL. I'd probably download all four of these, and we'll chat through like sort of this process. There we go. So I have this file here. I'm just going to save it to my desktop. And let me see. Okay, let's see where this ended up. My desktop, not yet finished downloading. There we go. And then I'm just going to go ahead and open this. It's like I broke Finder, which always happens. Okay, cool. There we go. So inside of this folder, you'll see there's this like very unhelpful name of vintage floral epoch 10.safe tensors. This is the file that Civitai gives you. The problem is that this file does not tell you anything about what the base model is, right? So this is why I added this folder name to make sure that we knew exactly what the base model was, which is SDXL. So let's go ahead and upload this to our Run Comfy system. So what we're going to do is we're going to go back to Run Comfy. We're in the LoRa's files here, and I'm going to make a new folder. Name yours SDXL. I'm going to name mine SDXL test because I already have an SDXL folder here. So name yours SDXL. And sorry, to create a new folder, you go to the hamburger menu here, you click on it, and you go to New Folder. You will name yours SDXL. I'm going to name mine SDXL test, and then hit Create. It'll automatically move you into that folder. And then what you want to do is come up here to the kebab menu, click on that, and then go to Upload. And then you'll select the file to upload. And then you'll select just this file. And for me, on my okay-ish New York City internet, it looks like it's going to take about a minute to upload. This file is 230 megabytes. That's about the size of an SDXL LoRa. If you download the SD 1.5 LoRa, you'll see it's probably like 80 megabytes. And that's because those networks are smaller as well. So if you have a custom model, you should do pretty much the same thing. If you made an SD 1.5 model, then you should make a folder called SD15. I'm always nervous about making points inside of my files. I know it doesn't really matter anymore, but I always try to avoid it. And then you should upload your file into there. You'll see I've got a bunch of other files or folders in here, like 1.5 Juggernaut Reborn, Juggernaut XL X, Juggernaut XL V6. These are all different base models that I've trained a LoRa on top of. And if you go back into this LoRa's folder, you'll see there are some labeled Juggernaut XL dash X, Juggernaut Reborn, Juggernaut XL V6. All of Eden's models are trained on top of that Juggernaut V6. Thankfully, RunComfy already comes with Juggernaut V6 loaded, pre-installed, so you don't need to worry about uploading a base model. If you train something on Juggernaut XL-X or Juggernaut XL10, you do need to download the model, which is here. Whoops. And there's two different versions. There's Juggernaut X Run Diffusion Hyper or Juggernaut X Run Diffusion. You just want that one. So it's this one. So let me copy this just in case anyone needs it. I know, I think I covered that in our tutorial where I did that. So if anyone else did that, you'll need to download this base model and upload it, which is going to be annoying because it is 6.5 gigabytes. Okay, I think my model is up. So let me just double check. It is, but I named my folder incorrectly. So let me rename my folder. Test. Okay. Is everyone getting to the upload stage? For those of you on local, it's probably easier. You just drag it into your folder, right? And it's there. Cool. Anyone that's following along and you haven't uploaded your LoRa hasn't uploaded yet, will you just give me like a hands up just so I can see? Okay. So Jorge's is still uploading. Cool. I'll give us one more minute and then I'll show you what we need to do next. Okay. Once you've uploaded your file to RunComfy, there's one more thing we need to do before we can actually access it, and that's this refresh button. The way Comfy's system works is okay. Oh, Jorge's good. Okay, great. Comfy doesn't really look through all of your folders unless it's told that it has to update it. So basically at runtime, it goes and grabs all the files and figures out where everything is. If you upload stuff during a session, you need to click this refresh button in order for it to tell you to relook at all the files. For whatever reason, I also find you need to click it like more than once. I have no idea why, probably like some weird bug in the system. So clicking it like 2 or 3 times seems to be the best behavior. So just do that. And then we'll be able to look and make sure that our model is there, or our LoRa is there. Okay, so once you've hit the refresh button a couple times, now let's actually load this into Comfy. So we're going to need a new node. We're going to double click outside of our node system here, and we're going to look for load LoRa. And that's going to be this load LoRa thing. I'm going to make mine big because my file names are insanely long here. So to make sure that our model is here, let's go and let's click on this LoRa name and we'll type in SDXL. Now, the problem is you're probably going to see a bunch of SDXL files because there's also the default built-in SDXL LoRas inside of RunComfy. So if you uploaded that vintage floral one, you can see, you should be able to look through the file names and see that there's a vintage floral epoch10.savetensors. If you uploaded a different file, like one of your custom LoRas, whatever your file name is should be visible here. If it isn't yet, that either means your file isn't uploaded into the right location, meaning it's not uploaded into that LoRa's folder, or it's not yet finished uploading, or you didn't press the refresh button multiple times, which also happens. I press it once and it doesn't show up and I'm like, what the fuck? Hit it twice and then it shows up fine. If you can't find your LoRa, like let's talk during the break and maybe I can help you figure it out. I'm going to go ahead and choose this vintage floral epoch 10 file. So our LoRa is now available to us, but it's not connected to our pipeline. So you'll see here on the left side for the inputs, we have a model input and a clip input. So as I mentioned, this is also an SDXL file. So we want to make sure that we're doing is that our load checkpoint is an SDXL file. And I can tell you right now, this one is not, it's 1.5. So we also need to load in the SDXL model. So click on this guy and then type in SDXL. You'll see there are a million XDSL files preloaded into Run Comfy. The one we're looking for is this one, which is called SDXL/XDXSD underscore XL underscore base underscore 1.0 dot safe tensors.
Why do we want that one in particular?
Because that is the original SDXL model. All the other ones are like fine tunes on top of that, which means if you connect a fine tune to this LoRa, which was trained on SDXL, you might get weird results. So this one was trained on the base model, so we're going to connect it to the base model. So now
Quick
that we've
question. I just downloaded that from Hugging Face, and there's one with underscore 0.9 VAE. Would that also work?
It might. I would probably try to find the base. I mean, let's try it and find out. I mean, you
I
can
see.
also try plugging these things in and see how weird your results get. You can compare your results to my results and see how far off they are. But probably the base 1.0 is probably the one you want. Okay, so we're going to connect our model into our LoRa. So we'll go model to model, and then we'll connect our clip out of our base model into our clip into our LoRa. So the thing we want to know about for this pipeline is like models always go in sort of a straight line, or like they always connect one to the next. So what we need to do now is our output of our LoRa is also a model and also a clip. So what we're going to do is we're going to take our model out of our LoRa and plug it into our K sampler input. And then we're going to take our clip out of our LoRa and plug that into both prompts. So what we've essentially done here is we've stuck our LoRa in the middle of this flow, right? We basically just like added a LoRa and then stuck it and kind of like added it on top of this model flow. So the
Sorry,
model flows.
can you do that
Sorry,
one
go
more
ahead. Yep.
time? Could you just repeat that really quickly?
Yes. So we're going to take our base load checkpoint and we're going to go model out of the base checkpoint into the input of the load LoRa. Our clip out from there into the input of the load LoRa clip. And then we're going to replace all the other inputs from our K sampler and our text encodes with the new ones coming out of the LoRa. So the model out of LoRa replaces the K sampler input, and the clips out of LoRa replace the inputs for both of the text prompts.
Derek, would you say it's accurate to say, like using a sort of guitar pedal metaphor, that LoRas basically act as a filter that are interposed between whatever the model was previously attached to?
Yes, guitar pedals are a great example for those of us that know that era of music, I guess. I don't know. It's also like a music synthesizer, other things, right? If you patch a filter through it, you're going to use that filter. But yes, that is right. And we'll see this actually when we do IP adapters as well. IP adapters do the exact same thing. We're going to basically like add another layer to our model pipeline and be able to do stuff with that. Okay, so now we are hooked up. Now, the other thing we need to remember is that our text prompt needs to be edited to match to our LoRa, right? So in the case of this LoRa, the thing I know is that my keyword is this vintage floral, all one word. So for this to work, I need to add vintage floral, all one word, into my text prompt, into the positive. If you train on Civitai, you probably gave it a different keyword and you need to use that keyword. And hopefully that is the first word in your model file. This basically triggers this LoRa to like work within the right model space. And now that we've got that there, we can go ahead and run our prompt. So Dia, for example, you have an embeddings file, and what you'll end up having to do is at the very beginning, you'll type in embeddings, and then hopefully your embeddings show up. Yeah, there's like a flowers embedding. I'll walk you through that during break or at some other point during class. Okay, so we can go ahead and hit Q prompt now. Oh wait, there's one more thing we need to do. I'm using an SDXL model, which means my my size dimensions are 1024 by 1024. So under the empty latent image, we want to do 1024, 1024. And what I'm also going to do is I'm going to increase my batch size to 4. That's going to give me 4 images. And the nice thing about 4 images is that's going to give me a little bit of a variation. And I can see how well my LoRa is actually working across more than just one image. This is kind of a replacement to like button mashing Q prompt a couple times. Okay, so now I'm going to hit Q prompt. Your loader probably took a little bit longer than mine did because I've been jamming on this for the past couple hours. So my XL loader is already cached. So yours is probably still stuck here. Just wait for it to finish and then it'll go through the rest of this pipeline. And my results kind of suck. Like this doesn't really look like my image at all. And there's a reason for that. The reason for this is my prompt doesn't really correlate with what my images were. So let me see if I have examples of what my images were. Let me see if I've got them here. Where are they? Where are they? Here we go. So the images I trained on look like this. But I'm not really seeing that reflected in this model. Let me also, for my own sanity, just make sure everything's hooked up correctly. Clip model. Yeah, okay. So it's not an issue with me being hooked up to things correctly. Instead, what it probably is that if you look at the text prompt here, you'll see that my prompt is still beautiful scenery, nature, glass bottle, landscape, purple galaxy bottle. So for whatever reason, I think that prompt is overriding whatever else is happening here. So we can kind of change our prompt a little bit to let's try beautiful flower in glass bottle. And let's also add in, even though our keyword here is vintage floral, let's add in some like vintage flower illustration. Beautiful flower in glass bottle. Let's remove this. And let's just say paper texture background. So even though we still have this LoRa, 9 times out of 10, the LoRa isn't really going to be strong enough to like override a lot of what's already built into your prompt. So you kind of also want to direct your prompt into something that matches this more. So let's run this one again. And now I have much better results. So text prompting still matters quite a bit, even when using LoRAs, because your LoRa can, or your text prompt can override LoRAs. There are some ways to play with this a little bit more. Like if we wanted to go back to that, let me just copy this and let me see if I can go back to that original prompt. Okay, so that was the original prompt I used. There are also in the LoRa, in the load LoRa node, there's also a thing called strength of the model, as well as strength of your clip embeds. You could try to crank this up a little bit more and see if that increases the influence of your LoRa on your text prompts. Let's try this and see. Less so, but it's getting closer, right? We can see the backgrounds are now beige. So again, I think that galaxy prompt is really kind of overly influencing the look and feel of this model. So let's go back to our original prompt. I'll just paste this in here for anyone that wants to use it. The other thing that could be happening here is I only trained this model. I had like 550 images, and I only trained it for like 10,000 steps on Civitai. It could be an undertrained model, in which case, if I train the LoRa for more time, it might get stronger and might influence my prompt here more. I don't know. It's like, would you rather spend time and money training your LoRa for longer, or would you rather just use a different prompt? I would say also that I have learned just by downloading other people's LoRAs, some LoRAs are really, really strong and other LoRAs are not as strong. And I don't know exactly why that is. Maybe it's got to do with training parameters. Maybe it just has to do with the type of images you use. Like Sarah's mentioning, she did 10 images and hers is shockingly good. Like, I think it is a little bit of a mixed bag of like how well they work and how well they don't. But I have had good results in combining LoRAs and text prompts together to get out a good result that kind of matches what my input images are. Just going to generate another set here. I'm also going to close my file browser so we got a little more space. Cool, so I'm back to this. So let's see if there are any other cool default LoRAs that are built into Run Comfy that we can play with. Because one of the things we can do, this is now just a chain, right? It is the effects pedal metaphor. We could actually add another LoRa in here and have that affect our images as well. So let's see what else is in the SDXL folder that comes in Run Comfy. Sorry, Arsha, you might be stuck here trying to download models really quickly. But let's just sort of experiment and see what else is in here. So if I click on this again and I just type in SDXL, this will show me a bunch of SDXL LoRAs that we can use. So here's one that's called Pixel Art Redmond Light 64. I guarantee you all of these are on Civitai. So if I just Google this and I say Pixel Art Redmond Light 64, and I open this in Civitai, we can see this is the kind of images that get outputted. So let's see if we can actually add this as another layer into our network system. Now, often the other thing that's here is there will be important trigger words that we need to use. This is kind of where Civitai is really helpful because I can go find this model and it'll tell me, okay, you need to use these trigger words. So use the word trigger words pixel art and pixa RFK. So I'm just going to copy the pixa RFK one because I don't remember that. Let's use then, in the load LoRa, let's add the, do this again, SDXL, let's add the Redmond, Pixel Art Redmond Light 64. And we're going to do the exact same thing here. We're going to take our model output from our load LoRa initially and our clip from here and plug these back in. And then we're going to replace the other inputs in the other places with this. So we'll do this to our model and our clips both to here. And then what I know we need to do next is we need to use that keyword. So I'm going to paste that in. It's pixa is what the keyword is. Pix RFK. And then they also said to use pixel art. So let's try this now. I imagine we're going to get like, I would hope what we get is this, are these sort of flowers, but then rendered in like a pixel art kind of look. So let's try this.
Does the order in which you chain LoRAs matter?
Probably. Well, we can try it and find out, but I would imagine yes.
Do LoRas have the same security concerns that the base models do, or the models rather?
No, actually, those security concerns were more with nodes than with models.
Oh, right.
You can't really, if you try to load a model that isn't like that is insecure, it's going to do something weird. It's just like not going to load correctly. Cool. So look at that. We now have pixel art flowers that look like my initial images that kind of do this. I bet, let's try to flip these around. I wouldn't actually recommend anyone do this. I'm going to do this for us. But I don't know if it's actually I don't know what it's going to lead to. It might be like weird blobby flowers. So let's try, what am I doing here? I'm trying model in, clip in, model out, clip out, model in, clip, clip. All right, let's try this. I'd say it's slightly softer on the pixel art, but it's, probably still very pixel arty. So again, maybe if I'm combining stuff like cyberpunk and flowers, then that order might matter. Is it more flowery? Is it more cyberpunky? I'd imagine also with the weights, you can kind of change things as well. So like, let's say I want only a little bit of pixel art, right? So I could do 0.6. And let's leave the flower LoRAs really strong. Still quite pixel arty, still pretty heavy on the pixel art. But I can actually see it's a little bit softer in terms of contrast, right? Like usually we'd get that really contrasty look for pixel art to make things really stand out. We could try cranking this down even further, do like 0.25. The other thing we could probably play with is like weighting within our prompt. We could try just like doing this and doing Control Shift up, making that a little bit stronger. Maybe taking this and making this a little bit stronger as well. Let's Q prompt that. Let's see what we get there. Yeah, that's kind of funny. It's like flowers on top of pixel art in some ways. If you zoom in a little bit, you can kind of see it's like doing some weird stuff there. Definitely not the most attractive looking images, but if you kind of want to mash up ideas, you can kind of do that here. One thing I also like to do is I think it's helpful, like as you're playing, to also kind of reduce your variables. Like, how much of an influence does my LoRa really have compared to my compared to my prompt? So let me turn this back down. So one thing I could do is I could set both these to 0. And this, I believe this should work. This should essentially turn them off. The other thing we could do is if we wanted to really understand if this was working, well, actually, let me run this once and see if this actually works the way I expect it to. Yeah, so you'll see my images look a little different. They have a little bit more of a 3D, like higher detail kind of look. So I do think my LoRas are actually having some influence and effect on the images that are beyond just what the text prompt is giving me. Um, Now, the other thing we could do here is we could actually just remove both these LoRas by replugging stuff in without this. So there's actually two ways we could do this. One is we could actually just plug in the model and just skip this completely. The other way that's a little bit nicer to do because it doesn't require like unplugging a million things is if you right click on your node and you go down to bypass, they'll actually skip both these nodes.
Does it matter how you use the LoRa keyword in your prompting? Like you always start with it separated with a comma, or can you use it in a sentence?
You could use it in a sentence. In general, text prompting the first couple words are going to be the most important, which is why everyone jams it into the first word. So
Mhm.
usually I would recommend like, but again, if you want to play with how much of an influence it has, you could try sticking it at the end. You could try sticking it in the middle. You could try sticking it into a sentence and see if that affects the overall influence of it. Probably does. But yeah, in general, I would say like it's better to not do that. So I actually think even with the strength of 0, it was still affecting the image. This is a common thing is like often you think strength is like 0 to 1, but there's often some algorithm in there that like sets limits like floor and max. So even saying the strength is 0 doesn't actually turn it off. I think bypassing it turns it off essentially. And that's true of a lot of things. Like you'll think you understand this how strength actually works, and then you find out you don't by bypassing or turning things back on and off. So I do recommend that you like play with this because understanding how your LoRa influences your images is pretty helpful in understanding like how to get the best results out of it. So for example, we could turn this one back on, which is our vintage floral model. And if we remove our pixel art shit from here, hit Q prompt, we should get back to that original sort of test that we had.
Sorry, another question. Does it matter if the keyword is semantically related to the LoRa?
It does
Could
not.
it be just, it does not. So it could
It
be
could just be
5, 6,
gobbledygook.
7.
Yeah.
I
What
see.
it can't be is a word that exists in LoRa in the Eclipse dictionary. So I wouldn't want to use the word floral because floral already exists as a space within that model.
Mhm.
I would want to use vintage floral all mashed up into one word, or I'd want a creative word that like I like to use like VNTGFLR or whatever, just so I can kind of remember what semantically it's supposed to be. Otherwise, you end up with like weird mashed up keyboard mashups, and like then you never remember what the hell they are.
I see.
So Claire, the keyword comes from our training. So when you train your model, it says like, hey, what do you want to call this thing? You give it a name, and then it uses that name as the embedded
Oh,
keyword. So in this case, the model that I trained, I gave it the word vintage floral as its keyword. And that's what we then use everywhere. So if you train a different model in Civitai and you gave it a different name, you'll want to use that keyword in your text prompt. Cool. Interestingly enough, this one still looks a little bit lighter. Why is that? I almost wonder if like even bypassing it doesn't really do anything. Let's see if this works. Oops, what did I break? Oh yeah, clip. Hmm, interesting. Oh, it's because it's because the strength is 0. Damn. Okay. Cool. Okay, so let's take a break. Let's do like a 10-minute break. And then we'll come back and talk about IP adapters, which are kind of like this, but on steroids. And we don't need to do any training, which is awesome, but also kind of frightening how well it works. So let's come back at 9:05 if you're on the East Coast, or just 5 after, wherever you are. And we'll pick up on IP adapters. Sound good? Cool. See you very soon. All right, I did a little node searching during our break. So I did actually find there is an SVG output node. So there is, if you go to manager, you go to install custom nodes, and you go to search for SVG. There is the ComfyUI to SVG. This project converts raster images into SVG format using the vtracer library. I don't know much about that one. I installed it. I ran it. It outputs. What I was also trying to do is I was trying to see if I could do canny images and then have it process the canny images to just get me lines. It looks okay. It's not perfect. It's like clearly kind of a mess. I bet we could do something fun with that, but like, I also need to play with my canny processing, that sort of thing. But so there is a way to get SVG out of it. Looks like it can also do color, so you could obviously like leave it as color and do some fun drawings with that. I don't know what all these settings are. I need to go and look at it, but I bet we could get something good out of this by default. But I also know like Golan, I know you said your student Ling Dong also has like a ton of like raster to SVG processors. So we could probably also look at like plugging one of those in.
I don't know how to make my own nodes yet, but are they written in JavaScript or what?
I would assume they're either in JavaScript or Python.
Okay.
One of the two. So I also have not really looked into it, but we should look into it. Maybe that'll be week 7 of class. I'll like figure out how to do that. We can try to make a node together. Yeah, so there is that. Also, Claire, you had a question about webcams. I found 2 nodes that do it. At least one of them said it only works locally, meaning you have to be running it from your local computer. You can't really like run it through Run Comfy. But it's cool. You could try it. I do not do a lot with webcams, but it could be fun to try it out and see what happens. There's also one from this guy or person by the name of Toy XYZ, who I really like. I follow Toy XYZ on Twitter, and they're always linking to cool stuff. So there's also that one, and I would guess that one's probably a good one as well, because I've seen a lot of their stuff and they know what they're doing. Cool. So it looks like it is Python for processing, and then JavaScript for the UI when you make your own node. So maybe we'll look at that in week 7, depending on what else we want to talk about. Cool. I'm going to just delete this stuff, delete this SVG stuff, and I will save this out as a workflow for everybody. So we've got it. Close this out. Save. Call this the LoRa workflow. And I have made a folder in our Google Drive, and it's linked to from the syllabus, and I'll also link it each week of all the workflows we make each week. So you'll have access to those as well. So I'll upload this later tonight once we're finished with class, and you can take a look at that workflow. All right, let's talk a little bit about, let me make sure I'm recording here again. Man, okay, cool, perfect. Yeah, so let's get started again. So we're just gonna load our default into Comfy. And let's talk about IP adapters. So IP adapters, you can think of this as sort of like one-shot image encoding, that sort of thing. So as you probably heard me talk about, like there's this idea of like training your own full model takes like 10,000 images, takes up many, many, many images with captions as well. Fine-tuning might take a little bit less images, but you still need a lot of images and a lot of captions. As we looked at this week, LoRa is pretty cool, and they only require 10 to like 100 images. So it's very easy to work with those. But IP adapters are kind of this crazy thing where like we can do this with one image. A single image will give us all the results we need within reason. Like we can kind of talk about that. But and obviously, like I think I was telling Golan about IP adapters, and he was kind of like, where does that name come from? I think it means intellectual property adapter. I mean, it's literally like we're gonna steal some intellectual property. I'm pretty sure that's what it means. I think the people who originated are also from like Tencent or some other Chinese corporation. So it also might have been some like language translation things that kind of happened in the middle of that. But IP adapters are really cool. We can upload one image and it can match that. So a lot of people do use that for faces. Like, hey, I want to put my face in this image, like that sort of thing. I like to use it for styles. Like it's pretty easy. It'll match styles pretty well as well. It's just a really all around like pretty interesting tool that you're able to do this. We're going to use this with the IP adapter plus node, which I think we already installed last week, but if not, I will go through it again with us. As I mentioned, the person who made it, who is known on GitHub as Cubic and on YouTube as Latent Visions, definitely doesn't have the best text documentation, but he has really great YouTube videos. He goes through every one of his tools on YouTube. He will often go through some of the more experimental features that he's playing with and trying out. So if you get really into IP adapters, I highly recommend checking out his YouTube channel. I will say he does a lot with women. They're like clothes, which is nice, but like he definitely likes to use women. So just fair warning on that. And yeah, like today I'm literally going to walk through one of his basic tutorials as we go through some of the IP adapter stuff. But I definitely think it's worth checking out the YouTube channel for sure. Because there's a lot of really good information that we will not cover in the next hour. Because I think he's got like 10 or 15 hours of material on his YouTube channel. So when we look at IP adapters, just like we looked at with LoRa's, there's this like concept of strengths and weightings, and that'll be sort of something we also want to play with when we play with IP adapter plus. The other thing we need to remember is IP adapter works off square images. So when you feed an image into IP adapter, it's going to crop your image to square and work off that square data. There is a way around it, and we'll look at it later today. There's a thing called IPAdapter tiled nodes, and that is what you can use if you want to map your IPAdapter image to a rectangular system. But by default, it's square. So often people will upload an image, and it'll be like a portrait image, and it'll crop off someone's head in a weird way. And like you have to remember that it's cropping your images. I think we used this last week, and we'll use it again this week, which is that there's a node called prep image for clip vision. We're going to use that again because that helps us understand where our crops are happening, helps us kind of zoom in, do other things with our tools. So we'll take a look at how all this works, and then we're just going to dive into it. So let's go back to run Comfy. And we've restarted to the default. So if you are not there with me, just hit load default, and that's going to load in our default setup here. So the first thing we want to add is we're going to add this thing called the unified loader. So double click in run Comfy and just type in unified, and you'll see IPAdapter unified loader. One thing I should mention, because we'll get to this probably later in other Garrett, I'll send you the node. I'll send to you. The person that made the IPAdapter plus node, does anyone not have this node? Should make sure that it's installed for everybody. Everyone that has it that's running run Comfy, you can find that node. Yes.
I don't have the node.
Okay, cool. So Jorge, go to your manager and then go install custom nodes. And then type in IPAdapter and hit search. And it's going to be this top one. You'll see it's got 3,400 stars. So it's by Cubic, and it's Comfy IPAdapter Plus. Wait, why don't I have it installed? How does that work? Maybe that's a mistake. Let's install it anyway, just to be safe. Okay, I'm going to restart my system. I don't know. That seems unlikely. Maybe it's because it's installed by run Comfy, it's not being found by the default tooling. So let me just restart here. And refresh the page. Cool. So Jorge, if you go through those steps, you should then be able to load it.
It's also said to me that this import failed. I have to restart Comfy again.
Yeah, you might have to restart Comfy again.
Okay.
Yeah.
Okay. Great.
Cool. Okay. We'll get this set up, and then I'll send you the workflow, Jorge, so you can catch up with us. So I think as I mentioned, the guy who made IPAdapter about 3 months ago completely rebuilt the entire library, which basically means any workflow that used IPAdapter prior to 3 months ago is now broken when you try to load it into Comfy. Huge nightmare. But I will say he made the new version much nicer. The old version used to have to load in like 5 different models by hand and remember all the combinations. This unified loader basically just says like, I'll figure it all out for you. So this unified loader will pull in all of the details we need for our IPAdapter models. When you click on the preset here, you'll see there are a couple different options, and a lot of them relate to strength. So low strength means the image we feed it is going to have a low impact on the output of the model. Now, actually, I have to say, I still think it's quite strong, but not nearly as strong as medium or high. So there's 2 mediums, standard and VITG, and there's a plus, which is high strength. And there's face ones, which we'll get to in a second, because face ones are a little bit different. I would say let's just start with the standard. So the next thing we need to add is the actual IPAdapter node. This just loads in the models. What we need to do next is actually load in our IPAdapter node. So we're going to double click here, and we'll type in IPAdapter. And frustratingly, it is nowhere near the top of this list. So you'll need to scroll down until you find IPAdapter. No other things, just called IPAdapter. Click on that. And we'll see here that we have an input of a model. So our output from our unified loader will plug into the input of the IPAdapter. we'll take the IPAdapter output of the unified loader and plug it into the IPAdapter. And one other thing we need to do is we need to plug in our model from our load checkpoint. Although I'm going to switch this around a little bit. So let's use our base SDXL model again. So we'll click on the load checkpoint. We'll type in SDXL and we'll scroll all the way down to SD_XL_base_1.0 safe tensors. And we need to plug this guy into our IPAdapter unified loader. And then we want to plug our output of our model of the IPAdapter into our case sampler. So again, we're kind of passing our model through this whole system. This system is going to change our model and then feed it to the case sampler. Now, the last thing we need for our input is we need an image, obviously, right? Like we've got an image here. We need to feed that image into, we need to feed an image into our IPAdapter. So for that, we're going to double click over here. We're going to type in load image. And we looked at this one last week. This just loads in an image for us. And if you use run Comfy's and run Comfy's image loader before, it'll just default to whatever your last image was. So we're going to plug in our image output into IPAdapter. And now we're pretty much all set up. So what we can do here again is I'm actually just going to take my last prompts that we made for the last session. So it's vintage. It's this one. I'm going to remove the vintage floral tag, which was meant to trigger the LoRA. So I'm just going to say vintage flower solution, beautiful flower in glass bottle, paper texture background. And we're just going to hit Q prompt. All this stuff is going to take a little bit of time to load. So I'm going to load in a bunch of models. Going to load in our IPAdapter models. And out of this, we don't really get our bottle, right? We get an image that looks kind of like this, but we really don't see the glass bottle. And that's probably because the strength of this thing is way too high. So we can try this with, let's try using actually there is no light version for SDXL. That's kind of annoying. So yeah, so what we can do instead is maybe let's crank down our weight. So you'll see here that we have a couple different options within IPAdapter. There's a weight option. So we can try, let's try turning this down to 0.6. And we still don't get a bottle. There's one other trick we can try before we start to do like crazier ideas here, which is, have I talked about start at and end at yet in class? Maybe I haven't. Okay, if I haven't, let's talk about it now. So start at and end at is about our steps. So start at means at what point in our steps should I start like trying to modify the image with my IPAdapter tool? So this means literally at the very beginning of my model, at the very beginning of my diffusion setup, I want to begin to influence it with this flower image. Well, that might not be the best thing for us because what if I wanted to build up a little bit of noise so I can actually build a glass bottle into my image? And then I want to influence it with the type of flower I want. So what you might see a lot of people do here is they will often do something like 0.2 or 0.1. That means in this case, I've got 20 steps total. So in this case, that means let it generate this text prompt for 4 steps before I start influencing it with the IPAdapter system. The other thing you might see people do is they might do 0.9, which means, okay, let it work off the noise and try to get to this prompt first for like 4 or 5 steps. Then have the IPAdapter, which is quite strong, begin to influence the image. And then at the very end, pull the IPAdapter out so it can generate something that's a little bit different. It can generate details that are a little bit better or a little bit different from this image. This is the kind of way you can begin to like affect the influence of this, but not have it just become this image. So by editing our start and our end at, we can kind of see if we can generate our glass bottle a little bit easier here. So let's try this now. Still nothing. So we've got some options here, right? Do we want to try to maybe take our prompt here and maybe crank this up, glass bottle one, add some weight to it. Still nothing. We could try inverting the order of some of these things. So we say beautiful flower and glass bottle, vintage flower illustration, paper texture background. Interestingly enough, now I get a picture frame. So if anything, we're kind of getting away from the glass bottle. So this is kind of a challenge here. So I wonder if there are other things we can put in here for our prompt. Maybe let's say, like, let's try to put this on a beach, right? So a beach scene background. And I feel like you see lots of glass bottles on beaches. So let's see if that helps. There you go. Better. Not perfect, but better, right? So now we've got a little bit of our glass bottle here. We've got this other thing. What if I know what I want my flowers to look like this? Or actually, let's try to change the flowers now. So I'm getting these obviously yellow flowers. What if I wanted a different color of flower? What if I want a red flower? Well, there's 2 ways I could do this. One is I could try to change my prompt. Cool. There's like multiple clairs now. I could try to change my prompt, or I could just change my image. Like this is where IPAdapters are really cool. Like I don't actually need to figure out the prompt. I don't need to say red flower and then have it make the whole image red. I can just go in and be like, let me just find a different flower. So let me choose a different flower. Let me go back to where my data set is. I'm doing a lot of scrolling to find my data set. Here we go. So let me go through here. Let me see if I can find a red flower. That's a red flower, but kind of ugly. Let's try this one. So now I want this flower in a glass bottle. So let's go ahead and hit Q prompt. It's really funny. I like that. You get like you get a big flower in the bottle and you get a little flower above it. We could probably change this a little bit if we update our strength a little bit more. Yeah. It's kind of nice. I like that very abstract beach we're on. My glass bottle is gone, but so it goes. Maybe I turn this down a little bit. Let's do 0.7. This also might be, we could probably change our batching here. Oh, you know, one other thing I'm realizing we did, or I didn't do. Let's try changing. So we're using SDXL, right? So it should be 1024 by 1024. That might be part of our issue. And let's generate like 4 images just so we can see what the diversity looks like.
It still starts at 512 for the first.
Thank you. Comfy, and it's forcing me into pressing. Well, that's actually kind of nice. It gives you the clear boxes of like 512, 512. There we go. Okay. Let's try it again. There you go. Some nice ones. Definitely looking more like my flower. And this is what's kind of cool about this IPAdapter program is like, yes, it's kind of ripping off what this image looks like, but it's not giving me the exact same options, right? It's not just saying like, hey, just remake this image. You know, because of this in my prompts, it's also giving me kind of this other idea of like what these images could look like. These are very surreal somehow. But let's say that I have a glass bottle in mind that I want to actually use. Well, why don't we add a second image of that glass bottle and then add that to my IPAdapter setup? So let's do that now. So what we're going to do here is we're going to copy and paste our nodes. So we're going to copy this load image node. I'll make these guys a little bit smaller. I don't need to see them that big. Smaller, smaller. And let me go find a glass bottle. So let's say glass bottle. What kind of glass bottle do I want? I don't like any of these. Glass bottle, flowers. Glass bottle, vase. That's a better word. Let's see if we can get this green one. So I'm just going to click on this. I'm going to open this image in a new tab. And I'm going to save down this image. WebP, of course. I don't think WebP actually works with these, with Comfy, but let me see. Oh, it might. Okay, cool. So we need now to load in the second image. So what we're going to do here is we're going to do what's called batch images. So we're going to do batch images. This allows me to pass two images as one, essentially. So I'll plug this one into image 2. I'll plug this one into image 1. And then I've got this images here. Now, the problem is that IPAdapter, the basic IPAdapter node, I can pass this in, but it's not really going to know what to do with two images. Like it's basically like I can input this, and if I run this, I bet it just spits out the first one. Let me just double check to see what happens here. It's either going to spit out one image, or it's going to spit out two batches that will include each image separately. Let me see what happens here. No, you know what? I think it might have actually taken that in. Technically, the way you're supposed to do this is through a different node. So technically, you're supposed to use the IPAdapter advanced node. And you'll see here that there is now a setting called combine embeds. And that is what we're going to actually use for our images here. So let's just delete this node. We'll plug all the same stuff in. So we'll plug our model into our model up here. We'll plug our IPAdapter into our IPAdapter here. We'll plug our batch images into our image. And we can skip the clip vision input because we're actually getting it from the unified loader. If we were to load our models in one by one, we'd have to plug in the clip vision one. But we don't need to do that. So we're going to use our model here. We'll output our model here. And then we're going to do sort of the same thing. So 0.7. The combine embeds, this is where we want to set this to average. So what it's going to do is going to average out the different images that we're feeding it. And we'll do the same thing here. We'll do 0.2. We'll do 0.9. And now we can go ahead and run this. Cool. And now we can kind of see that what we get is like kind of a mashup of these two images in this, right? So we kind of see our bottle here. The bottle shape isn't perfect. We can maybe say a round glass bottle and see if that gives us more of this roundish shape. Yeah, so that's a little bit better. but what if I really wanted to weight heavily toward the glass bottle and a little bit less toward the flower? In order to do that, there's actually no way to do weighting within these batches. The way we would want to do this is we would actually want to do what's called embedding. So what we're going to look for is we're going to delete this node. Actually, you know what? I'm going to save this one out. Save this as batch image IP adapter, where I delete all my work. Save that one. So if we want to do weighting, we need to change out how this works. So we're going to do, we're going to look for IP adapter. Is it encode? Which one is it? Embeds. That's what we want. Wait, that's not the one. That's the node we want here, of course. And then we want IP adapter encode. Encoder. Yes, that's what we want. So if you remember when we did the image to image tool, we did a VAE encoder, right? We encoded our image into the VAE. In this case, we're going to encode our images into the IP adapter tool. And we also need two of these. So I'm going to drag this guy down here. We're going to need one of these for each image. So we'll drag this one into here. We'll drag this one into here. We'll drag our IP adapter into both of them. And then what we want to do is we want to combine embeds. So we're going to look for I think we used this one last week, the combine IP adapter combine embeds. So in this case, what we're going to do is we're going to add both of them to our positives. So positive embed 1, embed 2. And now I've got different methods here. From what I understand, the main one you should probably use is just average. But what's nice here is now I also have the weighting capabilities here. So I can weight this image less than the other one. So let's say we want this one. So we want like more of the image to come from the glass bottle and less of it to come from our flower. And then we'll delete this guy. So we've got IP adapter embeds. We can take our embeds, which have now been combined and modified, into our positive embed. We can take our model up to our model, our IP adapter up to our IP adapter, and our output from our model into the K sampler. So now when we run this, we should see, and I'm going to play with this a little bit more. I'm going to do our start and end again, our weight again. So now we run this, we should see that the glass bottle has more of an influence over the final image than the floral illustration does. There we go. You can really see the effect that this glass bottle now has on the image, right? Because we weighted it so differently. And you can see the flower is still red, but it definitely doesn't have that same sort of look as it does. And this is really powerful. We can start to combine all these things in different ways. You'll see this IP adapter combine embed can take up to 5 embeds. You could then also actually make another one and combine that together. You could get really crazy here. You could have 10 different IP adapter images all being passed through at different weights. And that would allow you to then generate these images using all these different images. So it's a really powerful tool and really amazing, really interesting. What else did I want to talk about here? Oh, I want to talk about rectangles. We'll get to rectangular images in a minute.
Hey, Derek,
Yeah, go ahead.
if you wanted to apply like a specific color palette to an image, could you do it through this?
Interesting. Probably not,
Okay.
unless you had the colors applied to an image of the style you also wanted. Part of the problem is that the way this is working is it's taking every layer of the network into consideration, which means also taking structure as much as color. There is an experimental node from this creator that allows you to select individual UNet layers, which may actually allow you to do stuff like color influence. But I think that would be more challenging. I need to think about that. I think you could maybe get away with it, but it's worth testing and seeing, but I don't know that it would really work as well as you might want it to. It would probably bring in more of the structure of that image than just the colors. Okay, let's do one more thing before we look at rectangles and looking at that tiled node, which is kind of crazy. What we're also going to do here then is let's add in our LoRa. Let's add our LoRa back in so we can then influence the style of this thing. So for that, we know how to do that. We're just going to go load LoRa. And we're going to connect our model to it and our clip to it. And then we're going to connect model back to the IPAdapter node, right? Because now we want our LoRa to come in to be after the checkpoint, but before the IPAdapter. And then we need to connect our clip to our two prompts. And let me make sure I'm using the right one here. So we want SDXL. So we'll use vintage floral. So again, remember, we need to have our vintage floral at the very beginning of our prompts. And that's pretty much all we need to do. Let's see how this works. Not too bad. You can see we've now got that sort of beigeish background. The flowers have definitely taken on a little bit more of that illustration style of my images for my LoRa. Not every one of them is exact, and there's clearly some issues around structure. If we run this again, might get some better images. It's funny how much of the data I wouldn't expect it to pick up in a LoRa actually gets picked up. Like you can see the weird scanning issues that I had with these images. Got like little color bands along the sides. Yeah, so we've got some images here. We're able to combine all these concepts into one way to, so each way you want to influence the output of the image, you might try it with LoRa, you might try it with an IPAdapter, you might try it with using clip vision, or the clip interrogator, which is what we used last week. You might try it by feeding image to image into it. Like there's a number of different ways to manage the controls of these inputs. And all of these are like slightly different from each other. And will have slightly different effects, and you might need to play with them and sort of figure out what the difference is. Maybe you built up the system, and you really want to understand like, how much of my image is being influenced by this particular image. So I think we could even do like a bypass here. Let me even turn this image off. See if this works or it yells at me. Yeah, it's going to yell at me. Let's just directly connect this to our positive embed then. So now we can see when I turn off this flower, I get less of that red flower with sort of that white piping in the middle. And I get more of like kind of a crappy looking rose that's a little too three-dimensional, or other things, so you can begin to turn things on and off to see what the influence is. This is what I think is really powerful about Comfy and what is really hard to do in other tools. This ability to sort of quickly turn things on and off and still have the pipeline work for you. Like if you were to try to do this in code, you have to like comment a bunch of stuff out. You have to make sure it's in the right place, make sure it's all connecting the right way, make sure you're passing the variables around, even if you change out the sort of functions. So I think this is really, really amazing, and what you can do to really begin to experiment with these tools and layer in so many different features and also test stuff out really quickly. Like that's kind of the power of Comfy in these cases. So we're going to turn this back on. Would unbypass it. It'd be nice if this didn't break without it yelling at me. Let's talk about negative embeds. We've talked about negative prompts, but these IP adapters also create negative embeds, meaning the inverse of what we want the image to look like. And it's kind of funny, by default, the IP adapter encoder creates one of these. So we could actually plug one of these into our negative. And this will actually tell us to give us less of this, less of the opposite of this, which is kind of hard to think about conceptually, but it will tell us to do what the opposite of what this image is.
Do you need to disconnect the positive embedding, or you can leave it
No,
there?
because we want both. We want both the positive embedding of what this is, as well as the negative embedding of what it isn't. So you kind of want both to influence the output. You could invert the order and make a really funky image. Like, let's actually try this. Let's try the inversion. Like, let's put our negative to be positive and our positive to be negative. And let's actually clear out the prompts. Let's see what this does. Oh, I should make the weight on this one. Yeah. Let me turn off this LoRa as well. So this is kind of funny because this is what the IP adapter encoder thinks is the opposite of this image. Let's see if it change. It should change a lot when I change the weight. That's pretty interesting. So it thinks the negative of this image is either really psychedelic flowers, noise, or I don't even know what the hell this thing is. But it's kind of interesting. Like, this is really like a powerful tool to also think about how we understand, like, how the model thinks, right? If the model thinks that this is the inversion of this image, like, what does that mean? What sort of, like, it's still seeing trees, it's still seeing other things, but it's also adding color, like psychedelic colors, like pure noise, that sort of thing. It's really fascinating to like play with this in this way, and it's really easy to do. You just like invert the expected like input output paradigm, and you just like flip it around. So if we take this and we look at just the positive and negative directly connected, this should give us like this image almost over again. And again, we're doing all of this without a text prompt now. Like, this is purely like the encodings that are happening in IPAdapter. So it's skipping writing any text. It's going directly to giving us encoded numerals into our model. And here we see a bunch of different images based on this. So even that's kind of fun. This is a fun way to like make variations on your images. So this were your image. You could see how the model would make variations upon it. Cool. Let me just, I'll save this one out as no text encode only. All right, let me show one more thing here, which is how to deal with rectangular images. So let me just grab, let's see, portrait. I'm gonna grab one that's of someone. Let's see here. What do I want? All right, let's grab this one. See, I'm just stealing from people on Behance. Sorry. No different than what other machine learning models are doing. All right, so let's just set this up here, but I'm going to delete a bunch of these. We'll restart with a really basic IPAdapter node. So what I want to be able to do here is, let's say, black and white portrait of a woman with dark hair. And we'll say, do not want nude, naked, text, or a watermark. Okay. So what we're going to do now is we're going to load in our person. So let's do load image. And we're going to add our IP adapter. And we're going to plug everything in correctly. So we want model to model, IP adapter to IP adapter, and our model to go to our K-sampler model. Okay, so if I run this, I would hope, and let's change our sizes here. So let's say, I don't know what the actual dimensions are on this. Let's just try 1500 for the height. And let's try and generate this and let's see what happens. So we can see happens, we kind of stretch this person's face, right? We get an image that looks like them, but it's like super stretched. And that's because remember that I mentioned that these images get cropped to squares for this image. And clearly it's getting cropped in kind of a weird spot where it's like maybe not. Like we could do this. Let's do prep image for clip vision. And let's actually see what happens here. So if we want preview image, let's run this again. So actually, because of this prep image for clip vision, this is probably gonna look better, actually, maybe, we'll see. This prep image for clip vision, I believe by default, the image gets cropped from the center. But with this node, what we're actually doing is we're saying crop from the top, which actually might give us a better looking image. Let's see.
Didn't you connect the image to the
Thank
output
you. I
of
did
the
not do
image?
that. Thanks. Let's cancel this. Well, it's already running. All right, so it's still gonna look gnarly. Thanks. Good point. So I actually need to connect this node out into my IP adapter so it actually connects from here and not from directly from the image. Okay, so we still got some very long faces. That's just because the IP adapter is trying to essentially stretch this data across the entire latent space. So what we need to do now is actually fix this so that what we're getting is is basically a box crop here and a box crop here. Remember we kind of did that with masking last week, where we kind of said like, okay, we just want this space for the top part and this space for the top part, right? We kind of tile these squares in the right way. So the way to do that is we're going to get IP adapter man, I can never spell this, tiled. And we're going to replace that with this node with this. So we'll delete this node, place this one in here. And we will now connect all of our nodes. So we're going to connect our model from our loader up to our model, connect our IP adapter to our IP adapter. We'll connect our image. Actually, I don't think we want this one. I think we just want to connect it directly. And we will attach, don't need anything else here. So when we do our model out to our K-sampler, let's actually preview our tiles. This is always helpful to sort of see. I always recommend doing this, just so you can sort of see what's actually being made by this system. And I think that's everything we need. Yeah, let's run this. Oh, interesting. I did do it that way. See if this works. That did not do what it's supposed to do. Did I use, let me reference the Bible here of this guy's work, making sure I did this right. Batch nodes, IP adapter tiled. Okay, so he is still prepping it for clip vision. Well, it's not tiled. Huh. What did I do wrong here? Let's see. See, it should look like this. I should get two different images with different masks. So let me see. I wonder if this image is just really large. Let me try to actually have this image match this height. So let me do crop. So I'm gonna plug this in here and I'm gonna say width is, actually I want image scale, I think. Scale. Image resize. All the different words that could be. Yes, image resize is the one I want. Okay. All the different words that a node could be. Image to image, image to image. And I want my height to be 1024, and I want my width to be 1504. Relation nearest, condition of. Okay, let's see if this works. I think that gives me what I want. Let's dump the masks out too. No, that's still not right. Oh, we're getting late in the evening. I'm clearly screwing something up and I'm missing what it is. So I think what I'll do is we'll stop here and I'll figure out what I did wrong, and then I'll send everyone a video of what I did wrong, so I can fix this. Image negative. Yeah, I don't know why this isn't working correctly. All right, well, I'll figure that out later. Cool. So I will let everyone know how to use IP adapters with rectangular images. But probably for now, you're at least able to start playing around with this stuff, and can figure out what is going on with the IP adapter. Sorry, were there other notes here? Pixels of empty latent vision. Yeah, I don't know. Maybe it could be maybe that my dimensions are not matching up exactly with this image size or something. So I'll have to figure that out. But yeah, we did a lot today. We got through loading that LoRa and running the LoRa, and then we did a bunch of IP adapter stuff. We barely scratched the surface on IP adapters. I would actually say if there's other things you want to learn about, this guy, Latent Visions, his tutorials on here are really, really amazing. And he covers a lot of different stuff. So if you want to learn more about some of his weird wizardry tools, there's definitely a lot to play with. So definitely check that out. Yeah, so I'll figure out, sorry to end on a bummer of me not figuring out why something won't work, but I'll figure that out later. And I'll send it to everyone. So your homework for this week is really just to like play around with these two tools. Maybe now that you understand how LoRAs work, you want to retrain some LoRAs. Or maybe you want to, experiment with IP adapters more. So we can look at that more this week. So again, please play around, try stuff out. I think the IP adapter stuff is really fun, especially once you see the negatives, the positives, those sort of things. And we'll figure that out from there. But yeah, if you've got images or other things, please share those as well. Last note is I am not available Thursday night. I'm at a wedding. So if you want to do Q&A stuff, I left a note in our Slack channel that there might be other days that'll work better for me. So if you do want to do a Q&A this week, just let me know there. And then we can still find time to meet. Otherwise, we don't end up having an actual like Zoom class for Q&A, please add any questions you have in our Slack channel, and I can answer those there. Sound good? Cool. Thanks, everybody. See everybody next week.
Good night.
Bye.
Have a good night.
Night, see you. Thank you.